Now let's move to the understanding of an algebraic concept known as the identity. And when you talk about identity, what does it mean? And what is its application and its implications? Now, what is an identity in mathematics? What is the meaning of an identity? In algebra, some equalities are always true no matter what number you plug in. In algebra, you can get some equalities and they always shows true form no matter what number or what variable you plugged in. An identity is an equation that holds true for all values of the variable. It holds true for all values of the variable. An identity behaves like a universal truth for all values, but equation is only true for some specific values. So here we are supposed to know the difference between identity and equation. For example, we have x squared minus 4, as we are all going to say, is equal to x plus 2 in one bracket under x minus 2. This expression here is an identity. Why? Because it is always true for any real values of x. What it means is that put any variable or any number as your x. The answer that you are going to get at your left hand side will be the same answer as your right hand side. It means that any number, any real number that will be substituted as x, the expression here, both the left side and the right side become true. So that makes this one an identity. So that is the reason why when it comes to the point 3, we are saying that an identity behaves like a universal truth for all values. So that is one thing that we need to put in mind. An identity is an equation that holds true for all values of the variable. So here the variable is x, and this whole expression becomes an identity because it holds true for the left hand side and also holds true for the right hand side, no matter the number that you plug in. Now look at the next example. We have x squared minus 4 being equal to 0. It's an equation, so this one is not an identity. Why? Because it is only true for some specific value of x. And these values are plus 2 and minus 2. So it means that it is only plus 2 and minus 2 that will make the left hand side of the equation become the same as the right hand side of the equation. So the whole concept about this expression can be called or is known as an equation. Now, identities are very useful when expressing or simplifying rational functions, algebraic fractions, and partial fractions. So anytime you are dealing with rational fractions or functions or algebraic fractions and partial fractions, identities normally comes in the picture. So here, see to solving for unknown constants in an identity. And this concept is the real algebraic magic of rational functions. So here, for example, we are supposed to find the values of the constants a and b such that x minus 2 is equivalent or equal to a bracket x minus 4 plus b bracket x plus 3. Now let's look at the method to be used to solve this particular problem or to find the constant a and b. We are going to use two particular methods here, and the first one is known as the cover up rule. Cover up rule. It's like using your two eyes to, or using your eye to see an object in a bottle that is not too plain. you have to close one of the eye before you can use your one eye to see the object in the bottle. And that is the same format that we are going to use here. So now, this method is very fast and intuitive. And what we need to do is we plug in the values of s that eliminates. So here, eliminating one of the variable, whether a or b, is known as the cover up. So the solution will be in this format. First, look at this particular identity, and I want to cover up a variable a. Then it means that I need to plug in a number that will help me to totally eliminate a. So when you look at this, a can only be eliminated when it is multiplying 0. So how can this expression be 0 when x becomes 4? So I said, let x be equal to 4. Now, the moment s become equal to 4, it means that my substitution will be in this format. 4 minus 2 equal to a 4 minus 4 plus b 4 plus 3. Now 4 minus 4 here will give us 0. And when 0 multiply a is going to be 0. It means indirectly I have eliminated a. And remember, 4 minus 2 will give us 2 equal to, then 4 plus 3 give us 7b. Then I'll make my b the subject, and I'll end up with b equal to 2 divided by 7. Now, let x also represent minus 3. Why am I doing that? In order to cover up b to find a. So if I want to cover up b, this expression is supposed to go to 0. So that when b multiplies 0, the result will be 0. So here, when I let x be minus 3, then we are going to have minus 3 minus 2 at this side. Then a equal to minus 3 minus 4 plus b minus 3 plus 3, which everything here will automatically end up 0. So here the minus 5 will be equal to minus 7a. Then a will give us 5 divided by 7. So we have both answers for a and b. So hence, this particular identity is now complete, and it is x minus 2 equivalent to 5 on 7, x minus 4, plus 2 over 7x plus 3. Now, let's proceed to the next method of solving the same problem. So the second method is about expansion and equating coefficient. You expand and you equate coefficient because both the right hand side and the left hand side are the same. So here, this approach works by expanding both sides and comparing coefficient of x and constant. So here we have to expand the right hand side. So expanding the right hand side will be ax minus 4a, because a times x, ax, a times minus 4 give us minus 4a, b times x, bx, and b times this give us 3b. So when you do that, we are going to also group like term, the x at one side and the constant at the other side. So the ax plus bx has been grouped at this side. We have 3b minus 4a being grouped as also in this format. Then we do a little bit of factorization, and a factorization is bringing out the common factor outside and putting the rest of the expression in a bracket. So when you factor out the x, we are going to end up with a plus b, then the x is outside, plus the constant in also another bracket, in another bracket too. So if here, what are we going to do? We have our right hand side being expanded, simplified in this format. So we are going to compare this right hand side to the left hand side of the equation, and matching it to the left hand side, it means that here is x and this side too is x. So what variable is here? What number is in front of the x? What is the coefficient of the x? Is 1. Then what is the coefficient of the x here? Is a plus b. So we can't equate them. So it means that a plus b is equal to 1. Then I'll have my equation 1. Then I'll do the same thing to the constant. When you look at it carefully, we are going to have minus 4a plus 3b being the same as minus 2. So when you divide each term by negative, then the expression becomes 4a minus 3b equal to 2. Then we get equation 2. Our duty is to solve equation 1 and 2 simultaneously. So solving them simultaneously, solving equation 1 and 2 simultaneously means that here I'm going to use elimination format. I'll multiply equation 1 by 4 because I want to eliminate 4. So when we multiply the equation 1 by 4, we are going to get 4a plus 4b equal to 4. Then a minus a will give us 0. So a is eliminated. Then 4 minus 3b will give us 7b. Then here 4 minus 2 will give us 2. So b will be equal to 2 divided by 7, which is the same as what we got from the use of the cover up rule or method. So the same thing, put the b in one of the equation to get your a at 5 divided by 7. So this is the second method which we can use to find the constant of or in an identity. And let's proceed to the second example. We have to find the values of a, b, and c such that 5x plus 3 is equivalent to a, x plus 3, b, x minus 1, and plus c, x minus 1, x plus 3. So here, what is the first thing that we are going to do? We are going to use the cover up rule to cover whether A or B. So let x equal to 1 to cover B and C. So the moment x becomes 1, this one will be 1 minus 1 is 0. It is going to cover B. Then 1 minus 1 here is 0. It's going to cover C. Then it means that we are going to left with only A. So that will be 1 plus 3. Then 5 times 1 plus 3. So 5 times 1 is 5 plus 3 is 8. We are going to get 8 equal to 4a. Then a will give us 2. Then here too, we are also going to cover a in what way? By to let x equal to minus 3 to cover a and c. So here we are going to get 5 times minus 3 plus 3 equal to b minus 3 minus 1. Then we are going to have minus 12 equal to minus 4b. We divide both sides by minus 4, then we have b to be 3. Then the next thing is using cover up rule, fine. But now I am going to expand the right hand side. I am shifting myself to the second method to find c. So here the expansion will give us something of this nature. We have as plus 3a plus bs minus b plus cx squared plus 2cx minus 3c when you multiply the c across. So when you group like terms, you are going to have cx squared plus a plus b plus 2x, that is factorization here, plus 3a minus b minus 3c. When you compare this side to the left hand side, we only have variable x power 1, not x power 2. So it means that cx squared is not, x squared is not having uh, a comparable element at the left hand side. So here we can say that the coefficient of the x squared at this side is 0. So hence c equal to 0. So which means we understand this concept. So now let's move to the example 3. So the example 3 here too, we can also apply the same principle to find the values of the constant a, b, and c. So here let x be minus 2. So x being minus 2 implies that I want to cover up c and b to find a. So here I'm going to get 1 equal to a minus 2 minus 1 all squared. That will give us 1 equal to 9a, and my a will be 1 over 9. And I can also let x to be 1. X being 1 means I want to cover up a and b to get c. So doing that will give us 1 equal to c, 1 plus 2. And our result is going to be 1 equal to 3c. Then c is 1 over 3. Now, we are also going to use the expansion method to find b by expanding the right hand side and comparing terms to the left hand side coefficient. So now we have a in this format. I have to expand this before I can multiply the a. So when you expand x minus 1 whole square, you end up with x squared minus 2x plus 1. Then when you expand this to, we end up with x squared plus x minus 2. And when we expand the c to, we have x to be, we have c multiplying x plus 2. So here, the whole expansion is going to be ax squared minus 2ax plus a. Then bx squared plus bx minus 2b. Then cx plus 2c. When you group them, we are going to find out that the term of the x squared will be ax squared plus bx because they are like terms. So when you factor the x squared out, we are going to have a plus b x squared. So here, when you compare the left-hand side, there is no x squared term here. So we can write that the coefficient of the x squared at the left-hand side is 0. So hence, a plus b equal to 0. What is the value of a? Put the value of a here, make b the subject, and b will be minus a. So b will be minus 1 over 9. So that's brings us to the end of the lesson on identity concerning algebra. We have a practice session for you to try your hands on them. Try your hands on this particular question, then send your results to us for us to analyze and go through for you. We are here to help you to understand the concept of high school math so that you can pass your examination and be more analytical. So here, find the value of the a, b, and c such that x squared plus 1 equal to bracket of ax plus b close. Then we have x minus 1 plus c x squared plus 2. Wish you all the best.